In this video, we are going to continue on with our polynomials. In the last video, we learned how to add and subtract polynomials, and in this video, we're going to learn how to multiply polynomials. So your objective is that you can find the product of any two polynomials and then apply multiplying polynomials to geometric figures. So in this first example, it's just kind of get you familiar again with multiplying any polynomial, and this one is different variables, so it's not considered a polynomial. But when you see a number out front, you can think of the distributive property. So with the distributive property, we multiply to every term inside the parentheses. So I have negative 21y minus 6x plus 15w minus 3z. So with polynomials, it's the same thing. We're going to use the distributive property. So when I have 2x and x minus 2, these are two separate polynomials. This is a monomial and this is a binomial. I am going to multiply or distribute to both of these. So I'm going to go 2x times x, and we learn from our exponents, x times x is x squared. So this is 2x squared. Adding your exponents, and then 2x times, and we consider this a negative 2, 2x times negative 2 is negative 4x. In C, I'm multiplying 3x squared, a monomial, times a binomial. So I have 3x squared times x, that is 3x, 2x is here, 1x to give me x cubed. 3x squared times 3 is 9x squared. So on D, may look a little different, but instead of having the term out front, it is now behind. So I'm still having a monomial times a binomial, so I can multiply it to both of these. So negative 4 times 2x is negative 8, and then I have 3, so x cubed. Negative 7 times negative 4 is plus 28x squared. Alright, so E is when it starts to get a little different. When we have a binomial times a binomial, the distributive property doesn't work quite the same as you might think. A lot of students assume you just multiply the x's together and multiply the last ones. However, there are two other terms that happen. I am going to show you two methods of doing this. You can pick either method. It doesn't matter to me. One has the advantage over the others at times, and one can be a little bit faster at times, but also can be a little slower and messier. So the first method I'm going to show you is called the distributive property, which is where you like, I just seen the distributive property. However, I like to consider it as the double distributive. So here we have 3x. 3x is going to be distributed to both terms in the second polynomial. So I go 3x times 2x to give me 6x squared. Then I go 3x times 3 that give me 9x. Then I'm going to distribute the second term, the 1. So I'm going to go 1 times 2x, which is 2x, and 1 times 3 is 3. Lastly, I need to combine any like terms. I only have one x squared term, but I have 9x and 2x to give me 11x, and then plus 3. That is what these two polynomials are when you multiply them together. The second method, which a lot of students like to use because it keeps it nice and organized, is called the box method. And then what you do is you draw a box. Now the dimensions on the box changes based on what polynomial you have. Now in this first polynomial, we only have two terms, 3x and 1. So I'm going to have two columns in my box. On the second one, I have a two-term polynomial, so I'm going to have 2 rows in my box. Then on the outside of the box, I am going to put the polynomial. So on the top, I'm going to have 3x and 1. And then on the side, I'm going to have 2x and 3. Then inside each box I am going to multiply the given polynomial. So I have 3x and 2x. So in here I'm going to go 3x times 2x, and you don't need to write this out, but I'm just showing you. So that gives me 6x squared. In this box, I would multiply 1 times 2x, and that would give me a 2x. This box, I have 3x above, so I'm going to go 3x times 3, which gives me 9x, and 1 times 3, which gives me 3. Then, from the box, I'm not done there. I need to combine like terms and write my final answer. So notice I have only one x squared term, so I have 6x squared. Then I need to combine 2x and 9x. I'm not multiplying, I'm adding. So that gives me 11x, and then plus 3. Notice on both one, because we're just using two different methods to do the same problem, I got the same answer, and notice the terms I got when I distribute are the terms I got inside the box. So on F and G, on one I'm going to use the distributive property, and the other one I'm going to use the box to show you both ways. So on F, I'm going to use the distributive property. So first I'm going to multiply the 2x to both terms in the second polynomial. So 2x times x is 2x squared. 2x times negative 5 is minus 10x. Then I'm going to take the 1 and multiply it to both terms. So 2x times 1 is 1x. 1 times negative 5 is minus 5. I combine like terms and make sure it's in standard form. Leading term had the highest power. Minus 9x, negative 10 plus 1, minus 5. So in G, instead of using distributive property, I'm going to show you the box. So my box, there's two terms here and two terms here. So I'm going to go a 2 by 2. So I have negative 3x and negative 4. That minus sign travels with it. Then I have 2x and negative 5. So in this box, I go negative 3x times 2x. That's negative 6x squared. Negative 4 times 2x is negative 8x. Negative 3x and negative 5 is 15x. Negative 4 and negative 5 gives me 20. I have negative 6x squared. It's 15x and 8x is 7x plus 20. Again, I want to strongly reiterate, you can use either method. I don't care. If you like to use the box, use the box. If you want to distribute, you can distribute. A lot of students have seen the distribute before, and I am totally fine with you using that. Just pick the method that you're better at and use it. I do want you to become familiar with the box a little bit because we are going to use this when we get to Unit 5. So on H and I would strongly use the box because here we have a lot of terms. When you're done, you're going to have 6 terms, and it gets really messy. So I always encourage students to use the box. Helps you stay organized. You do not have to. You can distribute 3x to both of these, then the x, and then the negative 6. So on H, using the box, I have 3 terms here, so I need 3 columns this time. But I only have 2 terms in the second one, so I'm going to only have 2 rows. On the top, I'm going to write 3x squared, x, negative 6, 2x, minus 3. So I have 3x squared times 2x, that is 6. I have 3 x's, x to the third. X times 2x is 2x squared. Negative 6 times 2x is negative 12x. Negative 3x squared times 3x squared times negative 3 is negative 9x squared. X times negative 3 is negative 3x. Negative 6 times negative 3 is 18. Now I can combine like terms. I only have one x cubed term. I have 2x squared and negative 9x squared to give me negative 7x squared. Negative 12x and negative 3x is negative 15x. And then only one constant term. So in I, again, I don't encourage you to distribute, but I'm just going to show you for those students who might be curious, you can use the box. It does help you stay organized. But what you would do, I have 3a. I would distribute it to all three terms in the next polynomial. So I go 3a times 5a squared, which gives me 15a squared. 3a times 2a gives me, 15a cubed. There's 3 a's there. And then I have 3a plus 2a, which is 6a squared. And 3a times negative 3, which gives me negative 9a. Then I have 4 times 5a squared, which is 20a squared. And then I have 4 times 2a, which is 8a. And 4 times negative 3, which is minus 12. So combining like terms, I only have one cubed term, so I have 15a cubed. Need to look at my x squares, or a squares. I have 6 and 20, so that's plus 26a squared. I have negative 9 and 8, so that's a negative a. Again, we're going to encourage you not to use the 1. And then minus 12. That's my final answer. So again, you get the answer. It's just sometimes it gets a little messy. The more terms we have, the more it gets, where the box kind of keeps it nice and organized. So it kind of depends on what kind of person you are. You can use either method. We're going to skip those two, and we're just going to review. The distributive property, so when you're multiplying polynomials, you can use the distributive property, which remember is just multiply each term to the other terms in each one, or you can use the box. It depends on your own preference. Just a reminder to do your reflection so you get credit for watching this video.